name is Riku Voipio, and I work at Linaro in the so-called Builds and Baselines team, and I'm also the Qemu LinuxUser maintainer. So there are 3 different ways you can use Qemu. I think almost everyone here uses the first way of Qemu as a virtual machine. You accelerate with KVM. You run virtual machines that may emulate real machines in characteristics, but may also be quite virtual so that they have virt.io and vhost and so on. The second mode is similar. We are still using machines to emulate, but we might be a different architecture, or if we don't have hardware virtualization support, it can be the same architecture. Qemu has the tiny code generator, which allows you to use a completely different architectures, binaries, or virtual machines, or real machines that are being put into some kind of disk image. And now for something completely different, there's the LinuxUser mode, which this talk is about. We execute binaries, Linux binaries, and we are emulating the Linux kernel. So the first 2 modes emulate systems. They try to emulate hardware, while the last mode is just the kernel emulator. There's also a BSD user mode, which is less commonly used and doesn't currently have a maintainer. How did we end up there? Well, originally we started with just being LinuxUser. The first version of Qemu was to run X86 binaries on PowerPC, and the goal was to run Windows applications eventually. It may even be possible these days now that we have rather threaded support in Qemu. So this was almost 15 years ago. How did we evolve from there? So in about 2005, when I started using LinuxUser Qemu, we were getting a problem of cross-compilation. At Nokia, we wanted to cross-compile applications for various phones as easily as possible, and the Qemu was found. So 0.7 Qemu, almost usable. People were always talking that this is a temporary solution and we'll move to something else quite soon. Around 2009, the Qemu gained the tiny code generator, and it was no longer as big hack as before. But on the other hand, people started using KVM, and the LinuxUser part of Qemu became a kind of a sidetrack that most people don't deal with daily, and the Qemu development doesn't really look a lot into. So I joined Linaro, and eventually Peter convinced me to become the maintainer of Qemu LinuxUser. And things were quite quiet. There were things like people were saying that Qemu LinuxUser will go away, or you shouldn't use it because we don't have threads. And that changed eventually. So first there was a big revitalization of interest in Qemu LinuxUser when we got the ARM64 architecture. There was no hardware available for anyone, and the emulator provided an easy access for application developers. And finally, last year, well, the excuse of don't use LinuxUser Qemu, it doesn't support threads, went away when we got finally a contribution of proper threading support in Qemu. So why do people use LinuxUser Qemu? As I mentioned earlier, augmenting and helping cross-compilation has been a big motivator for a very long time. It is often possible to cross-compile applications without Qemu, and people who do Yocto and Open Embedded will tell you that Qemu is completely unnecessary. Are you saying something?
Yeah, actually this is because a lot of configures don't support cross-compile.
Yes, so when you do a naive cross-compilation, you have to run configure and somehow manage to either have the values in a kind of cache, or then you can run Qemu and generate them for yourself. But perhaps a more interesting use case is bootstrapping new architectures. There's always, when someone starts a new architecture, there's an issue of the hardware not being available. And even if the hardware is available, it's often slow and prototypey and buggy. So doing it on a workstation which is fast and having an emulator lets you usually get along a lot more faster. On the other hand, often these people who use Qemu to bootstrap their architectures don't necessarily bother to work on upstreaming the code. There have been various forks of Qemu supporting exotic architectures that have not been ended up in Qemu. Then a rather new use case is building container images when you don't have the target architecture machine around, or you're using some kind of community-provided infrastructures from Docker Hub or Travis, and you would like to support, say, Raspberry Pis. Then people use Qemu LinuxUser to build their container images. And finally, as was mentioned in the earlier, that if you have some old HPPA binaries around and you want to still run them and you have sent your HPPA machine to a museum, well, LinuxUser Qemu can help you run those applications. Often in the Linux area, it's not that interesting because most Linux applications are open source and you can compile them, but that's not always the case. There are proprietary Linux applications, and sometimes you may have lost the source code or other reasons such like debugging or reverse engineering some applications for a foreign architecture. The status currently is that we have about 30 targets we can build to. A target may be, for example, we have 6 different targets for MIPS, and on the host side we have 9 targets, which is one is the interpreter, which could theoretically run on any architecture, but is rather slow. If we take the easiest case we have, then ARM64 host, ARM64 target and an AMD64 machine. Both are 64-bit and both are little endian. A recent run of my LTP testing gave 58 failures in 1,158 tests. That's about 5% of the syscalls are failing. And usually most applications that people try on Qemu LinuxUser do work. One of the current issues that we have been investigating is Java. So there has been possibly a regression, or then it hasn't never really worked properly, but we have a bug on it. It's kind of a weird thing to emulate since it's an architecture independent language, and you could theoretically just run the ARM64 Java VM or X86 Java VM and not try to run it under Qemu, but people have all kinds of reasons why they have to use the target architecture different from what they have currently. So how does LinuxUser emulator work? It tries to emulate the Linux kernel. There's the system call interface, IOCTLs, some files under proc. The interface is rather thin compared to many other things that people try to emulate, and this is actually very similar to what Microsoft recently did when they started supporting Linux in Windows with their Windows subsystem for Linux. So here's a typical example of what we would do to emulate something in Qemu LinuxUser. The getRandom syscall is rather new, and it didn't exist before, so we needed a patch to add it. It's also a rather simple system call. We have a memory area where we write some random bytes, the size of the buffer, and then a handful of flags. we have an application that tries to call getrandom. It sends a syscall and Qemu intercepts it. There's some mangling that needs to be done. Do we need to convert the NDNS? No, because we are both, if we are having the same NDNS on both ends. The constants might be different. In this case, it's not the case. The flags are same on all architectures. In some cases, they aren't. And then we just call the getrandom from the kernel. Actually, we don't usually call the kernel directly. We call the libc function to do it. Then the main reason for this is that in some cases the host kernel might be a lot older than the target system is expecting. You might want to call something, let's say the getrandom in the libc might have a fallback to support older kernels while the system call would not. So the kernel then gives us some random bits back in the memory buffer, and then we go around the other way back. Does there need to be an NDNS conversion? Is there some constants that need to be translated? And finally, did we get an error, and how do we translate it to the correct error number? And it gets back to the application. Then we continue to executing the TCG microops until the next system call, IOCTL or whatever. And in Qemu, it's going to look up like this. This is actually from the Qemu source codes. The LinuxUser is our function to allocate some memory to write to. We don't actually allocate anything. We might copy in some cases, but usually we don't bother. Might be a page fault if we've asked for a too big memory area to write to. And then we call the getrandom libc function and use the geterror function to convert the error number if we got an error to the correct one. And finally, in the unlockUser, which tries to look a bit like copy to use. This LockUser and unlockUser look a bit like copy to user and copy from user in the kernel. So in this case, we don't need to do any NDNS conversion in any cases because it's random bits, and even if we would swap the NDNS, it's still going to be random. So typical issues we bump into when implementing system calls, as mentioned, we have the big NDNS issue. Most of the users of Qemu have been using little endian machines and little endian targets. So there's a lot of, say, bit rot from the idea that we should support big endian guests and big endian hosts, and it doesn't quite work. There are a lot of places where people have forgotten them. We have the get user and put user functions that if you use them correctly, it will do them. And if you have something more complicated, we have the tswap, apparently with a typo. And then we have the usual case of that, more usual case that instead of just random bits we get from kernel, we get some kind of struct, or we have to pass a struct to the kernel. So we need to write a function that converts the struct from the way it's expected in the target architecture to the way that the host will use. And finally, there's all kind of weird cases of special registers or memory layout accesses which are different from each architecture. So how do we test all this? We don't really test it a lot, but if we have 30 targets and 9 hosts, that gives us a huge combination matrix of combinations that we could test. Currently, most testing goes around the ARM targets and X86 hosts, and sometimes on MIPS and PowerPC targets and these things that people happen to be developing on. The quickest way to test is with a static Busybox binary, because Busybox is a nice tool that has a lot of the user land that is typical for Linux, but in a single binary. So you can typically test a lot of system calls with the Busybox itself already. It's quite fast to set up because it's one binary. And you can usually find a static binary for the architecture you're working for. For more complete testing, we have been using the Linux testing project. Linux testing project has lots of binaries to test all kinds of system calls that the kernel supports. It does a lot more though, but this is the area that we are interested in. We take a example of what we can do with up. With Busybox. The list of all the tools that the Busybox provides is quite long, which of course many of them are just some string or file handling. They don't give you any bigger information, but you have a lot of more complicated commands, for example IPA to discuss the kernel, what interfaces and what IP addresses are there. We see that by running, it got relatively correct looking answers. There's no garbage or so on. And we get probably useful error messages. Yes, you're not root. The error translation works fine. If you're brave, you can run Qemu with sudo. And yeah, we got a raw socket also correctly. So in general, you can be happy with this combination. So I also have a static Busybox collection on the wiki pages from Qemu.org, which you can download if you want to try a specific combination that you can't compile or find yourself. LTP is the bigger monster to set up, and the way that I do it is that I have a Docker container that starts from the standard whatever architecture I'm targeting right now. This example is from ARM64. We copy a Qemu binary there, install the build dependencies and compile in Qemu. This is a very slow way to compile LTP, but on the other hand, because I want to test Qemu, using Qemu to run all the GCC and make and these commands is a useful way to find out earlier that if it works or not. If the compilation fails into some seg files or something, I can be quite suspicious. This is also like a typical example of using Qemu for building Docker containers. And the nice part of this container building is that you only need to do it once, and then you can run the newer Qemu binaries with the existing container. Apparently this does not look very good on the slides. We use the privileged mode because without it, lots of the system calls are not simply available. And this is one problem with container testing, is that container does not allow you necessarily to use all the instructions all the system calls you would want to test. Here we have the one neat trick is to use the volume flag in Docker to copy your currently newly built Qemu and use it as the Qemu that is being run for all the tests you're going to run. The This way you can use the existing container and just link the latest new QEMU you're testing. And you just run the run LTP, collect some logs, and you may have to have a skip list of a handful of tests that will hang either because of Docker issues or QEMU issues. It takes about 20 minutes, and if you do it for all the 30 targets we have available, it's a bit unwieldy for doing it in, say, every day. Hop. So there's the discussion of what should be the future of QEMU in the LinuxUser part in QEMU. First of all, if you are new to QEMU or KVM project, the LinuxUser part is a very easy place to come to. There's a lot of low-hanging fruits you can join to. The code hasn't really been cleaned up or refactored ever. Any kind of patch you make will give you some kind of check patch warnings because of the code around you is rather ugly and not check patch ready. Another easy way to find a lot of things to fix is to try something else than X86 as host or try a big endian target. I'm sure you'll find a lot of fun bugs to fix. And then there's the options that we could discuss of making it less ugly. The syscall.c is one huge if case select, and there's a signal.c that could be split architecture specifically instead of having each every architecture in the same file under a different ifdef. So if we are going to start to be serious about the LinuxUser usage, we should find a way to do the various testing we do less ad hoc and more tightly integrated into what we are already doing in Travis and so on. But as said, the LTP tests take 20 minutes for one architecture. Find some kind of subset of tests that make sense to run for every build that touches QEMU user code. Then we have the usual follow the kernel, because kernel is always changing and bringing new interfaces, new architectures. It's not static, and on the other end we have to discuss if there's some old code that could be removed. We support, I think, Red Hat Enterprise Linux 5 as the oldest baseline. If that can be bumped up, we can clean up some old ifdef cases. One interesting thing to do is to have better support for Android userland applications. Technically, we use the Android has the same interface. It uses the kernel. It has a slightly different libc, but it does use things like binder, and those have not been implemented in Qemu LinuxUser. Then, as said, we need some people to work on the BSD user parts. There are some odd architectures like Unicore 32 that hasn't seen a commit for years. And if eventually we get that libtcg, there's the discussion if it would make sense to have LinuxUser as its completely independent project. So, any ideas or discussion on this front?
Well, I'm mostly interested, of course, on the X86 host side. On the testing, how do you do this so far? Is this all run in sequence on your system? Or, for example, could you imagine you could push the test cases also in a Travis containers or Travis runtimes in parallel? Have you parallelized these kind of tests, or how does it look like?
Well, my machine can take like 4 or 3 of those together, but if I would have infinite resources, I would of course run them all together. The LTP is quite linear, but it has some phases where it starts running hundreds of threads at the same time.
I have a question about the Docker. I like to run Docker to run the LTP test suite. Is this description available in the Qemu source or?
Not yet, so my intention is that we should get this integrated with the make Docker things that exist in Qemu already.
And is there any documentation explaining how to do that? To run the test with LinuxUser in a Docker?
That's basically these slides and then the wiki page that was mentioned. I don't think it mentions Docker specifically. It was a CH root, but the idea is actually very similar.
Okay, thank you.
Yeah, and at the very beginning you mentioned that one of the original ideas was to run Wine with
Yes.
this. Is it working well nowadays? Can you run Windows binaries on other platforms? Do you know?
Well, I haven't actually tried, so that's actually maybe something to find out.
Okay, thanks.
So in your demo, you showed an output of the IP command, and you said it looks correct. Have you actually checked? So basically, can you just diff the output of native command execution with the Qemu user stuff? And I mean,
Well,
on an automated base to kind of make sure that IP is not swapping bits in the IP address or whatever, for instance.
well,
Yeah, but this is one of the things. So if you just
I would assume that LTP has some network link tests.
Yeah,
and
but
if it
that's
doesn't,
my question. So we rely on LTP solely for correctness checks, and
yeah,
and
I
this,
think that
this smoke testing that you just mentioned is just some.
just a quicker way to do things, because setting up LTP and running it is a bit of a burden.
But so you don't do Busybox testing on a regular automated base.
Well, I do run the Busybox applets that relate to the functions that people are patching to.
Oh, okay.
So that's usually if I'm lucky enough that the function that is being modified by people is something that the Qemu is using, that's a very easy way to find out that if it's correct or not. On the other hand, Busybox is often using quite old versions of the system calls to do things, and if the system call that is being implemented in Qemu is newer than what Busybox supports, then of course that doesn't work. Any other questions? Well, I guess that's then it then.